For my project, I was given video assignment number 15. For this first part, it asks us to compute the integral of 2 to 5 of 1 over the square root of x minus 2 dx. And so for this first part, we're going to write down our integral, 1 over square root of x minus 2 dx. We're going to replace 2 with t, because if 2 is plugged into this equation, it'd become 1 over 0, which doesn't exist, and which makes this an improper integral. And so we're going to replace 2 with t to give us, and we're going to take the limit t approaching 2 of the integral of t to 5 of 1 over square root x minus 2 dx. Now we're going to solve for our integral. T to 5 of x minus 2 to the negative 1/2, which is equivalent to a previous part, dx. And now we need to do a u sub. We will set u equal to the internal part of the function, which is x minus 2, which means that du will bring us to 1 dx. So now this will allow us to replace our internal function with u to the negative 1/2 and get rid of dx to replace it with du. Now we just simply solve for this integral, which will become u to negative 1/2 plus 1, or negative 1/2 plus 1, the limit of t approaching 2, which then become limit approaching 2 of u to the 1/2 over 1/2, which will then become the limit t approaching 2 of 2 times u to the 1/2 to the 1/2. Now we will place the internal part of our function with what we set u equal to originally, which is x minus 2, which will then bring us to the limit t approaching 2 of 2 times x minus 2 to the 1/2 from the bounds from an integral of t to 5. Now all we simply have to do is plug in our bounds to the equation, which will bring us to 2 times 5 minus 2 to the 1/2 minus 2 times t minus 2 to the 1/2. This will then become 2 times 3 to the 1/2 minus this part will become 0 because we plugged in 2 into here. This would just bring us to 2 times 0 to the 1/2, which would then become, this will leave us with 2 times 3 to the 1/2 minus 0, which then brings us to 2 times 3 to the 1/2, which is also equivalent to 2 times the square root of 3, which is our answer for the integral that the first part asks us to compute, which is 2, which is equal to 2 times the square root of 3. Now for the second part, it asks us if the following statement is true: if f of x is less than g of x for all x, and the integral of 0 to infinity of g of x dx diverges, then the integral of 0 to infinity of f of x dx should also diverge. Flip this paper to give me more room. Now to find the answer to this statement, I decided to set g of x and f of x equal to functions, one of which were g of x. I have it equal to u squared plus 2, and f of x is equal to 1 over x squared plus 1. This function, f of x, is less than the function of g of x. And so, now if we take the integral of 0 to infinity of g of x dx, we will get 2x, oh no, I'm sorry, I did the derivative. We will get x cubed over 3 plus 2x from 0 to infinity. And so when we plug in our bounds, we will have infinity cubed over 3 plus 2 times infinity minus 0 cubed over 3 plus 2 times 0. This will then lead us to infinity minus 0, leaving us with infinity, which means that this function diverges. Now that's just the first part. Now if we take the integral of f of x from 0 to infinity, then we will have the inverse of tan, because tan inverse is equivalent to this function from 0 to infinity. So now we plug in our bounds, tan inverse of x, oops, I'm sorry, not tan inverse of x, tan inverse of infinity minus tan inverse of 0. Now when tan inverse is, or for tan inverse of x, as x approaches infinity, well, it's actually just approaching pi over 2. So this tan inverse of infinity will just become pi over 2, and tan inverse of 0 will just be 0, which means that pi over 2, which leaves us with pi over 2, which means that this function converges. So now we have g of x can diverge. However, f of x can converge. If we look at a graph of these two functions, then we will see that, just a rough sketch, for g of x, this will be, so roughly look something along the lines of this, 2 g of x, and for f of x, should look something along the lines of this. This shows that g of x is for all x, f of x will always be less than g of x, always be less than f of x for all x. However, as we found before, g of x will diverge, but f of x will converge. And so for original statement that was given, it asks if f of x is less than g of x for all x, which we have, and the integral of 0 to infinity of g of x dx diverges, which we have, then the integral of 0 to infinity of f of x dx also diverges. However, from what we found that f of x will converge to pi over 2, and so that means that this statement is false.